Okay, here we are, section 7.3, the central limit theorem for proportions. These can be a little bit tricky because you have probabilities and proportions, and it can get confusing for some people. But here's an example. Question 39, this is on page 365. Abandoning landlines. They are abandoned, my friends. I bet you don't even know what a landline is. It's a wire that goes into your house, and the phone plugs into the wire. Yeah, it's crazy. Anyway, the National Health Interviews Survey reports that 25% of telephone users no longer use landlines. So 25% don't use landlines and have switched completely to cell phone use. Suppose we take a sample of size 36. This textbook is just a couple of years old now, so I'm guessing that number 25% is much higher, the percentage of people that no longer use landlines. But here's the problem. Find the mean and standard deviation of the sampling distribution of p hat. P hat. Okay? And then it says describe the sampling distribution of p hat. So, here's what we know. We know n equals 36, so we're going to talk to 36 people, and we know that the proportion of people who do not use landlines in the whole population is 0.25. That's our estimate. Sometimes you have these estimates and then you go take a sample to see how it plays out for your situation. So, the first question says find the mean of the sampling distribution p hat. So that's what this looks like. This is going to be the mean of the sampling distribution. And the rule from this section, 7.3, says the mean is just the population proportion, 0.25. So the average percentage is 0.25. And remember, p is a proportion, so the averages and standard deviations are always going to be these decimal numbers. So the average is 0.25, and the standard deviation of p hat is going to be, here's the formula, square root of p, the proportion, times 1 minus p, all divided by n, which is equal to, now we plug in the numbers, this was the regular formula, 0.25 times 1 minus 0.25, some of you might just think 0.75, all divided by 36. So the standard deviation, that works out to a weird little number, which I believe is 0.0772. I usually use 4 decimal places here, but it's, 3 or 4 is fine. So that answers part A. Find the mean and standard deviation of the sampling distribution of p hat. Here's the mean, and here's the standard deviation. Next part. The next part says to describe the sampling distribution of p hat. Well, you might think, we just found the mean and standard deviation. Isn't that what they're talking about? What they're really saying is prove that p hat is normal or not. So they're really saying for part B, is p hat normally distributed? Is it normally distributed? So we know, again, this is what we know, n equals 36. We know that the population proportion is 0.25. We just calculated that the mean of p hat is equal to 0.25, and the standard deviation is equal to 0.0722, I think is the right answer, 0.722. So to test if it's normal, so when they say describe the distribution, they're asking you to test if it's normal, if normal. Normal. And here's the test. You want to take n times p, and you want to see, is that bigger than 5 or equal to 5? Is it? Is it? Question mark. And then n times 1 minus p. You want to know, is that greater than or equal to 5? So, in this case, n is 36, p is 0.25. When we multiply those together, we get 9. Huzzah, that is bigger than 5. N is 36, 1 minus p, 0.75, is equal to 27. That is also bigger than 5. Yay, good job, huzzah, we passed this test. So to describe the distribution, because both of these numbers are bigger than or equal to 5, we can say that p hat is approximately normally distributed. The p hats are always going to be approximately normal. Is approximately normally distributed with a mean of 0.25 We calculated that in the first part, and a standard deviation of 0.0722. So that is how you answer this part. Describe the sampling distribution. It's approximately normal with a mean of 0.25 and a standard deviation of 0.0722. If these had not passed the test, if this had not been, if they'd been smaller than 5, we would say it's unknown. Then it would be unknown. But that's not our situation. Unknown. It's not our situation. Okay, next part. And here is part C of the question. Compute the probability that p hat exceeds 0.26. So, if we go here, let's let this picture be our p hat. This is the sampling distribution of the probability. We just said it's normally distributed with a mean of 0.25 and a standard deviation of 0.0722. I'm rounding. So here in the middle, we have the mean of p hat equals 0.25. And we want the probability that we talk to 36 people and that the sample proportion is greater than 0.26. So 26 is going to be, I don't know, here. Let's just put that there, 0.26. And what we want is eyeballing a straight line. That's all right. We want this probability right here. That's the probability that p hat is greater than 0.26. So you can see it's, it should be less than 50% certainly. And because we know it's normally distributed or approximately normally distributed, we can use our normal function on the calculator. This normal function is super handy. The normal CDF function on the TI 83 or 84. That's really a great way to find probabilities. So you'll notice we want to go from 0.26 up to infinity. Here's how you do it on the calculator. Here's what we're doing. I'll go back over this in a second. So on the calculator, type in second function vars, second function variables, that gets you to the distribution function. Then you go to the second one, normal CDF, and then you type in 0.26, that's the lower bound, and then this 10 raised to the 99, that's infinity. This part right here, that's saying infinity, because you want to go from 0.26 to infinity. So you got 0.26, infinity, this is the mean, 0.25, and this is the standard deviation, 0.0722. You hit enter, and then your calculator, what does it give you? 0.4499, right here. So we're saying that is 0.4499, approximately. I think that's right. 49. 49. Look, it's like a test. I'm scribbling answers all over it, and you have to read it. Okay, 4449. So what this is saying, I'm going to go back up here, is that if you take a sample of 36 people, what is the probability that the sample proportion who no longer use landlines is greater than 26? It's 4449. So you have essentially a 45% chance that your sample will have greater than 26% of the people who no longer use landlines. I know that's a lot of negatives, and there's a lot of proportions. So there's this proportion, and then there's this probability. So it can be confusing. But hopefully, this will help you with the steps that you need to solve this problem. We got the mean standard deviation. We looked at the n times p, and then we got the probability that p hat exceeds 0.26. That's how you do it, people.